Dapatkah kamu bayangkan, kampus pionir pendidikan tinggi di Indonesia ini adalah kampusmu di masa depan. Kampus Islami yang terbuka bagi setiap warga negara, tempatmu belajar akan arti indahnya kebersamaan di tengah-tengah keragaman. Tanpa harus melupakan arti penting ketaatan pada nilai-nilai keislaman. Dapatkah kamu bayangkan mengecap pengalaman global di kampus mondial dengan beragam rekognisi internasional di program studi dengan akreditasi dan sertifikasi dari berbagai negara seperti Jepang, Korea, Inggris, hingga Amerika. Tempatmu mengeksplorasi ilmu pengetahuan lewat 8 pilihan fakultas dengan 48 program studi yang ditawarkan. Menjadi tempatmu menjemput impian sembari bebas menikmati petualangan kolaborasi dengan ilmuwan dunia. Seraya memperluas wawasan lewat berbagai program kemitraan yang tersebar dalam skala nasional maupun global. Dapatkah kamu bayangkan, kampus swasta paling lestari di Indonesia ini adalah tempatmu menempuh pendidikan tinggi? Kampus unggulan dengan berbagai inovasi berkelanjutan di berbagai bidang. Tempatmu belajar dengan bebas, di tengah rindangnya taman atau dalam nyamannya ruangan. Di luar maupun dalam jaringan, semuanya tak terbatas ruang kelas, tak terhalang jarak dan ruang. Semua disediakan untuk mendukungmu menjadi generasi muda yang aktif dan inovatif dengan keragaman pemikiran yang berbuah menjadi beragam apresiasi. Dapatkah kamu bayangkan, jika kampusmu kelak adalah tempat yang mendukungmu sebagai intelektual, tidak hanya cerdas secara akal, namun juga cerdas spiritual di kampus swasta terbaik dengan akar yang kuat dalam tradisi kebebasan akademik, menjadikanmu berani mengekspresikan diri di tengah-tengah zaman yang penuh dengan kompetisi untuk berkontribusi akan solusi dari masalah yang dihadapi. Para sivitas akademika serta lebih dari 107.000 alumni pun telah membuktikan diri menjadi insan ulil albab yang mampu mengintegrasikan ilmu pengetahuan dan ajaran Islam dalam menebar kebermanfaatan di bermacam rumpun keilmuan. Dapatkah kamu bayangkan apabila kampusmu adalah salah satu kampus yang berlokasi di kota pendidikan ini, kota Yogyakarta dengan segudang cerita dan budaya yang beraneka ragamnya, dan Universitas Islam Indonesia hadir sebagai kampus Indonesiawi, berdiri berdampingan dengan ilmu pengetahuan, budaya, dan seni yang memberikan warna indah dalam harmoni. Kini berhenti membayangkan dan sudah saatnya bersiap untuk mewujudkan. Siapkah kamu? Karena kami siap untuk menunjukkan jalannya. Dapatkah kamu bayangkan, kampus pionir pendidikan tinggi di Indonesia ini adalah kampusmu di masa depan. Kampus Islami yang terbuka bagi setiap warga negara, tempatmu belajar akan arti indahnya kebersamaan di tengah-tengah keragaman. Tanpa harus melupakan arti penting ketaatan pada nilai-nilai keislaman. Dapatkah kamu bayangkan mengecap pengalaman global di kampus mondial dengan beragam rekognisi internasional di program studi dengan akreditasi dan sertifikasi dari berbagai negara seperti Jepang, Korea, Inggris, hingga Amerika. Tempatmu mengeksplorasi ilmu pengetahuan lewat 8 pilihan fakultas dengan 48 program studi yang ditawarkan. Menjadi tempatmu menjemput impian sembari bebas menikmati petualangan kolaborasi dengan ilmuwan dunia. Seraya memperluas wawasan lewat berbagai program kemitraan yang tersebar dalam skala nasional maupun global. Dapatkah kamu bayangkan, kampus swasta paling lestari di Indonesia ini adalah tempatmu menempuh pendidikan tinggi? Kampus unggulan dengan berbagai inovasi berkelanjutan di berbagai bidang. Tempatmu belajar dengan bebas, di tengah rindangnya taman atau dalam nyamannya ruangan. Di luar maupun dalam jaringan, semuanya tak terbatas ruang kelas, tak terhalang jarak dan ruang. Semua disediakan untuk mendukungmu menjadi generasi muda yang aktif dan inovatif dengan keragaman pemikiran yang berbuah menjadi beragam apresiasi. Dapatkah kamu bayangkan, jika kampusmu kelak adalah tempat yang mendukungmu sebagai intelektual, Tidak hanya cerdas secara akal, namun juga cerdas spiritual. Di kampus swasta terbaik dengan akar yang kuat dalam tradisi kebebasan akademik, menjadikanmu berani mengekspresikan diri di tengah-tengah zaman yang penuh dengan kompetisi untuk berkontribusi akan solusi dari masalah yang dihadapi. Para sivitas akademika serta lebih dari 107.000 alumni pun telah membuktikan diri menjadi insan ulil albab yang mampu mengintegrasikan ilmu pengetahuan dan ajaran Islam dalam menebar kebermanfaatan di bermacam rumpun keilmuan. Dapatkah kamu bayangkan apabila kampusmu adalah salah satu kampus yang berlokasi di kota pendidikan ini, kota Yogyakarta dengan segudang cerita dan budaya yang beraneka ragamnya, dan Universitas Islam Indonesia hadir sebagai kampus Indonesiawi, berdiri berdampingan dengan ilmu pengetahuan, budaya, dan seni yang memberikan warna indah dalam harmoni. Kini berhenti membayangkan dan sudah saatnya bersiap untuk mewujudkan. Siapkah kamu? Karena kami siap untuk menunjukkan jalannya.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Alhamdulillahirabbil alamin. Wassalatu wassalamu ala asrofil anbiya'i wal mursalin wa ala alihi washabihi ajmain amma ba'du. So ladies and gentlemen, welcome to the 2022 General Lecture of Textile Engineering Department, Faculty of Industrial Technology, Universitas Islam Indonesia. So today, Tuesday, June 7, 2022, we are proudly presenting to you a general lecture under the topic of Introduction to Electrospun Nanofiber and Potential Application with our honorable speaker, Dr. Engineering Muzamil Katri, from Department of Chemistry and Material, Faculty of Textile Science and Technology, Shinshu University, Japan. So, more than an hour, I am Rina, will conduct this beautiful event, so you can join our morning with us. First, we would like to say welcome to honorable guests. There are Dr. E.R. Faisal RM, MT PhD, the head of the Textile Engineering Department, FCIWI. So, Assalamualaikum, Pak Faisal.
Ya, Waalaikumsalam warahmatullahi wabarakatuh.
Terima kasih sudah berkenan hadir, Pak Faisal. And also our honorable speaker, Dr. Engineering Muzamil Katri. Hello, Dr. Muzamil. Welcome to our university event. This is still a virtual meeting, so we are really welcoming you.
Thank you so much. Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh. And also lecturer and student from Textile Engineering Department who are both attending in the classroom, and also some of them join us by Zoom meeting, and as well as all guests and also attendants who are joining this event from all over Indonesia, even maybe around the world. So, ladies and gentlemen, before continuing this agenda, so we would like to mention point of the event today. So first, we will be opening, and the second is opening remarks, and the third is lecture from the Dr. Muzamil, and fourth is question and answer, and the last one is closing. And we kindly remind you to mute your microphone during lecture, but you might tune your camera along the event. So untuk partisipan mohon untuk mematikan mikrofon dan juga bisa mengaktifkan kameranya. And if you have any question, please you can write it down in the box, chat box, and we will deliver it in the question and answer session. Or maybe if you are joining us in the classroom, so you can just raise your hand, and Miss February will help you to connect it with the Zoom meeting. And also we already sent the virtual background in the chat box, so please you can download it and put it on as your virtual background as well. And next into the next agenda, honorable speaker and the participant. So without waiting any longer, let's move to the next point of the activity, which is opening remarks. So this greeting speech will be delivered by the head of a textile department, textile engineering department. So to Dr. Andes E.R. Faisal, RM, MP, PhD, the time is yours. Please, monggo Pak Faisal.
Terima kasih Mbak Lina. Saya mohon maaf ya bahasa saya sambutan dalam bahasa Indonesia ya, karena kalau pakai bahasa Inggris saya takut dan banyak salahnya ya, malah jadi bahan tertawaan dari para peserta ya. Pertama-tama marilah kita panjatkan puja puji syukur kehadapan Allah Subhanahu wa taala berkat rahmat hidayahnya sehingga pada siang hari ini kita dapat melaksanakan kuliah tamu ya, yang tidak tanggung-tanggung. Kita coba ya mengundang ya lecturer, yaitu dosen dari Shinshu University Jepang, yang memukakan tentang hal yang baru bagi kita ya, karena kita dari program studi rekayasa tekstil hanya mengenal ya tekstil dalam pengertian sandang, tapi sebenarnya tekstil itu lebih luas dari itu lagi, tidak hanya sandang tapi non sandang untuk keperluan hidup manusia ya, sama hayat dikandung badan. Jadi kami program studi rekayasa tekstil ucapkan terima kasih dan selamat datang Dr. Eng Muzammil Katri ya. Dia masih muda belia, karena saya lihat dari tanggal lahirnya ya usianya baru 30 tahun ya. Ini perjalanan dinas masih panjang ya. Ya mudah-mudahan ini pertama kali dan seterusnya. Tentunya Dr. Eng Muzammil Katri ini tidak keberatan ya ketika kita nanti minta sebagai dosen tamu ya. Jadi tidak harus datang ke Indonesia, yang tentu memerlukan waktu dan biaya yang tidak sedikit ya. Sehingga ya kami mengundang beliau dalam kuliah ya tamu melalui Zoom atau istilahnya webinar ya. Jadi topik yang diangkat oleh beliau ini satu yang baru mungkin bagi kita ya, yaitu bagaimana ya membuat serat ya dari larutan polimer ya dengan menggunakan energi listrik ya untuk mendapatkan ukuran serat ya beberapa ratus nano ya. Dan ini tentunya sangat luas penggunaannya, tidak hanya tekstil tapi juga non tekstil ya. Karena sekarang lagi tren tentang teknologi nano ini, ya bagi kita mungkin satu yang baru, sebenarnya sudah lama berkembang. Inilah yang merupakan momentum bagi kami kalangan dosen dan juga mahasiswa untuk mempelajari lebih jauh lagi. Jadi kami harapkan dari mahasiswa dapat mengikuti kuliah tamu ini dari awal sampai selesai, karena betapa mahalnya ya ilmu yang akan diberikan oleh Dr. Eng Muzammil Katri. Jadi kami ya harapkan untuk ke depan bisa mengundang ya dosen-dosen tamu dari luar negeri ya, agar kita bukan lagi kelas lokal tapi sudah masuk ke kelas internasional ya, dengan mengundang pembicara dari luar negeri yang tentu tidak sembarang perguruan tinggi ya. Shinshu University ini tidak salah merupakan alma maternya Mbak Rina ya untuk ngambil program master maupun PhD atau Dr. Eng ya. Baiklah, saya kira mungkin tidak perlu berpanjang lebar sambutan saya. Jadi saya ucapkan terima kasih kepada Dr. Eng Muzammil Katri yang sudi mengundang kami, dan kami juga mengharapkan dari peserta akan mengikuti ini dengan baik, karena momentum ini sangat langka tidak mungkin ya akan terjadi untuk masa-masa datang. Jadi kita harapkan dapat diikuti dengan sebaik-baiknya. Kami kira itu dari kami, dari program studi Rekayasa Tekstil Universitas Islam Indonesia. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Dr. Faisal. So before continuing to our main lecture, so we would like to take a documentation of our beautiful event today. So for audience that join us by a Zoom meeting, please turn on your camera. And also, when from the student in the classroom, yeah, I think all people already stay in there. Okay. So for the taking the documentation, so I would like to ask Miss Febri to help us arrange this agenda. Please, Miss Febri.
Okay, thank you, Ms. Serena. All participants and our honorable guests, please turn on your camera. We are going to do a documentation session today. We are going to wait you to turn your camera on and please put the virtual background that already uploaded by the committee in the chat box. Okay, I'm going to take your picture now. Please give your best smile. Okay, 1, 2, 3. Two more times. 1, 2, 3. Okay, one more time, please. Okay. Okay, last one. Smile. 1, 2, 3. Okay, thank you, Ms. Rina. The time is yours now.
Okay, thank you very much for Ms. Febri that arranged this documentation. Okay. Thank you, ladies and gentlemen, as well. We are going to show you a bit of a video of our department of textile engineering department who hold this event today. So this department is the pioneer and the only one of bachelor degree program for academic in textile engineering in Indonesia. So please, on the profile, you can show it.
Yogyakarta, a city of profound stories about culture and history, it is well known with its batik, a unique traditional art carved by the hands of elderly artists who await the younger generation to take their role and the legacy as a timeless heritage. With a pride of heart and self-trust, we believe this is the right time to step forward and bring this heritage to future glory. That little step starts with making the right choice. Lying in the spatial city of Yogyakarta, which is renowned for its hospitality and diverse culture and traditions, Universitas Islam Indonesia has been established in 1945 with an integrated campus that stands on the area of 35 hectares on the north side of the city of Yogyakarta, holding the record for the best private university of 2018 by Kemenristek Dikti with a 3 stars rating by Stars. UII provides state-of-the-art facilities that support academic activities. And life necessities for all students and teaching staff. Universitas Islam Indonesia proudly presents the Textile Engineering Study Program as a pioneer program for undergraduate level in the development of textile industry in Indonesia. It concerns on studies in design and control for all processing stages in the textile manufacturing to become a textile product. The program offers the best facilities to support the learning process that is driven by lab work without putting aside the importance of batik as our cultural heritage. The learning methods are mainly conducted through lab works and simulation to improve students' understanding in applying theories derived from classroom learning. To prepare quality human resources in the textile industry, we provide the fashions and clothing field with state-of-the-art equipment and standardized test equipment that meets national standard accreditation requirements. Thus, the study program of textile engineering has a recognized test output and can contribute to academic researches conducted by students and lecturers, both for the internal and external institutions at the national and international research scope. Our professional teaching staff and expert in the field of textile engineering along with the expert are always ready to assist students both in terms of academic and non-academic aspect. In fact, every student is encouraged to take part in various national and international non-academic activities. Innovation to become a study program that develops technology and contributes to the positive changes in the field of textile manufacturing throughout Southeast Asia, as proven by wide-ranging collaborations with countless top-ranked universities worldwide as a way to provide the community with knowledge and technology. Universitas Islam Indonesia always comes up with the best graduates to develop the nations. With a magnificent fighting spirit, we will continue to gain more achievements and innovate to preserve the country's cultural heritage as a pride of the nations. In these young hands lies the hope to showcase the nation heritage to the world. Achieve your success today.
Okay. So that is a claim of our Textile Engineering Department, FCE UEE. So for the more information, please visit us our website at textile.uee.ac.id or our Instagram at rekatex at UEE. So ladies and gentlemen, the lecture will be delivered by Dr. Muzamil. But before that, we would like to show you a sort of his biography. So wait a moment, I will share it. Okay. Now his name is Muzamil Fatri. So he's now working at Department of Chemistry and Material, Faculty of Textile Science and Technology, Shinshu University, Japan. and his academic background. So he graduated from the Master and PhD at Shinshu University, Japan, Department of Science and Engineering, also Textile Science and Technology. He also graduated from the Textile Engineering from Merhan University of Engineering and Technology, Jashoro, or this is I think in the Pakistan, as well as from the high school from Pakistan. So this is the work history of him. So actually he is now researcher at Department of Chemistry and Material, Shinshu University, Japan. And I think he will be candidate for lecturer in there. And also he have been working as a teaching assistant. He also have business internship at National Institute of Material Science, Ibaraki, Japan. Also have academic internship at National University of Singapore, as well as other work history in here. And also he have a professional qualification as the guest editor at Polymer Journal, also member of Textile Engineering in the Pakistan Engineering Council, and also a lot of achievement in here we can see from the screen. And he has a lot of research activity in here. I think it's around or about the electrospun fabrication or characterization of electrospun nanofiber. So I think he conduct a lot of research using different kind of material, which is the polymers, synthetic or natural. We can see in here a lot of research have been done. For example, they conduct the nanofiber membrane for medical from the artificial blood vessel, or also from the dyeing, for example, in here. And I think a lot of the research have been done by him. Okay, maybe I can continue, and you can see from the screen. Okay, and also he wait a moment. Oh, he also have review paper around, I think it's also around nanofiber and electrospinning, and he already published one book about dyeing of electrospun nanofiber, handbook of nanofibers, and he have been invited as a speaker as well in, like, for example, from the conference in Dubai or in Pakistan and Mehan and a lot we can see from the screen. And he also have been presented at the conference or social meeting, such as in USA, Japan, and I think a lot of country. And okay, he also got a prize of award as, for example, in the Best Academic Achievement Award by Advanced Global Leader Program, Shinshu University, Japan, and another prize or award from Max. And also have international academic collaboration with Merhan University, Pakistan, University of Boku, Austria, National Institute of Material Science in Japan, National University of Singapore, Shinshu University in China, and another international collaboration that we can see from the screen. Okay, I think enough from his biography. Wait a moment. Okay, so without any further ado, please welcome Dr. Engineering Muzamil Khatri. And to Dr. Engineering Muzamil, the time is yours. Please, you can start your lecture.
Thank you very much, Rina, and thank you, Dr. Faisal, for introducing me and inviting me to give this talk, Introduction to Electrospun Nanofiber and Potential Applications. I never know about this in university. I saw many good videos, and it's very nice university. You are doing very good in textile engineering. Let me share my slides. Okay, so this is like a basic lecture for undergraduate students. I will talk generally about introduction to electrospin nanofibers and their potential applications. This is outline of research today. I will introduce the nanotechnology, nanofibers, their properties, electrospinning technique, and some parameters. And in the last, I will describe potential applications of nanofibers. So first, the question in our mind comes when we hear nanofiber. So first, we have to understand what is nano. Fiber, you are textile engineer, so you already know what is nano and what is fiber, but I want to describe what is nano. Nano is a scale which is very small. Let's compare an earth circle in front of a tennis ball. We can imagine that how small tennis ball is in front of earth. So will be the value of 1 nano in front of this tennis ball. So we can imagine how small nano scale is. And if we say 1 nanometer will be equal to 10 raised power minus 9th part of single meter, or we also can say 10,000th part of one human hair. So it's small scale which we cannot see with our eye. We have to use microscope to see or assess the fibers at nanoscale. This is video describing with some examples, like there are a variety of species on Earth. So we can see how small nanofiber is compared to these all small species on Earth, like ant, large bacteria, small bacteria, even is smaller than human egg. Here we can see on the right corner, the scale is being described. So where we will find 10 raised power minus 9th part, so that will be equivalent to 1 nanometer. There are large viruses, mini viruses. So these all viruses and bacteria we also can infiltrate using face mask and stuff. This is just filtration using cage, you can say, at nanoscale. So this here is a nanometer. This is diameter. We can see even water molecule is can not pass through this one, but air molecules can pass. So there are variety of magical nanofiber. We call them magical nanofibers. From those air can pass through, but water cannot pass through. So there are a variety of applications I'm going to explain in the next slides. Nanofibers have high surface area. This is the reason we use nanofibers in our research. So there is one question that what is high surface area? This is football ground, and the size of this football ground is 700 square meter. So if we take 1 gram of nanofiber, only 1 gram, it can cover all this area. So this is like surface area is very high, the size of nanofiber is small, so it can dissipate on all this cricket ground or football ground, which is about 700 square meters. Let's take another simple example. There is a kid, she is very keen of jam jelly. So her mother is putting jam jelly on both sides of one bread. But if she wants more surface area or more jam on it, what she is doing, she is cutting bread into 2 more pieces, like we can see in this animation on the left side. And then this one single bread will have 4 surface areas on both sides. So she can get more jam jelly on the single bread when she cut into 2 pieces. So this is how we get benefit from higher surface area. More the surface area, more the ground will be to play. And this is electrospinning setup. So first, what is electrospinning? You already know what is spinning. Spinning is a collection of fibers in the form of yarn or filament. Here we are utilizing electrospinning, means when we supply electricity, then we spin fiber in the form of yarn or fabric or filament. So how we use some polymers and solvents to prepare such kind of nanofibers. Here we can see there is one solvent there are variety of solvents available, and there is polymer. So when we combine these together and form a transparent solution, that is called polymer solution. When solvent and polymer combine together, it forms a solution, and that solution is called polymer solution. That polymer solution we put inside this syringe and supply a high voltage. This voltage have low current but high voltage. Like current is minimized. This is machine, electrospinning machine, where DC voltage is applied, but current is reduced. If the current is high, we cannot use it near to the machine. It will have hazardous to our body, and we will be hospitalized. So that's why the reason we are reducing the current, but we are supplying the flow of electrons from this positively charged electrode. There is metallic electrode we supply to that electrode, and that electrode is dipped inside the polymer solution. And this is collector is it's connected to the earth. Earth is negatively charged normally. So when flow of electron from positive side flow towards negative side, they take polymer solution through it as well. What we do in normal spinning, we stretch the fiber, we draw the fiber, and they just twist it and form yarn. Here is the same stretching mechanism, but the fibers are collecting not in the form of yarn, but in the form of non-woven layer. So these fibers are collecting continuously. Here we can see in this video that from this chip, when we supply a high voltage, these fibers goes and collected on this. Sorry.
Okay, please continue,
Okay.
Dr. Musana.
Yes. So when these fibers are collected on this collector drum, then we dry it for a number of hours or 24 hours. So the residual solvent, because we use this solvent, sometimes these solvent are health hazardous, sometimes are not. Water also can be a solvent, or any other acetic acid which we extract from lemon. So such kind of solvent we can use. But when we prepare nanofibers, so to avoid humidity and moisture or any solvent residual inside, because it also can cause smell, so we dry in the air or in the oven depending on the end use application, and then we utilize it for further application or characterizations. This is the picture in which we can see, this is tissue paper like picture. So non-woven layer of nanofibers exactly look like this. Because we are utilizing polymer to produce nanofibers, so we should have idea that what actually a polymer is. Polymer is combination of monomers. There are variety of polymers available on earth, natural, synthetic, and semi-synthetic. So if it's a collection of monomers, then we have to know that what a monomer is. Monomer is basic unit of any component or compound. For example, for natural polymers, we take cellulose as a polymer. So the monomer available inside is glucose. This is chemical structure of glucose, where there are OH groups and ring-like structure. So when this single monomer combine together, it forms a polymer. So there are variety of chains of this monomer inside this cellulose, and it forms cellulose. This is a structure of cellulose. So the combination of these glucose monomers in the form of polymer is called cellulose polymer. There are semi-synthetic polymers as well. Semi-synthetic means that we take natural polymer and modify it synthetically using synthetic chemicals. And examples are cellulose nitrate or cellulose acetate. And synthetic polymers are polymers which actually are derived from natural resources like crude oil or any oil, or from natural resources. But we drive them into different shapes and different polymers, such as nylon, polyester, polyethylene, like the plastic bags we are utilizing. These are called synthetic polymers. And we are also utilizing solvents. Solvent is some sort of liquid or fluid in which our solute can dissolve or polymer can dissolve in that. So depending on the application or depending on the properties of polymer, we have to choose the solvent. So it should have some specific properties for electrospinning. Only solubilizing it's not the goal. These are parameters of electrospinning. So I described already the electrospinning mechanism, but these are some parameters like polymer type. I described there are 3 types of polymer: synthetic, semi-synthetic, and natural. So we can utilize different type of polymer in different types of solvent, either polar, non-polar, organic, non-organic solvents, depending on the type of polymer. So choice should be intelligent. And the second thing is polymer solution properties. Polymer solution properties include, when we combine these together, we have to check the viscosity of the polymer solution, whether we are putting in the syringe and it's not just coming out, or it's coming out in the form of spray after we apply voltage, or it's also depend on the conductivity of solution, pH of the solution. These are several parameters we have to check when we make polymer solution for the electrospinning. And third number is diameter, size of needle tip. For electrospinning, we use some needles here at the tip. So needles have some diameter, like the cylindrical shape from which the solution is coming out is called needle tip. And the different diameters will give us different types of nanofibers, different form of nanofibers that I'm going to describe later. Voltage supply, feed rate, and tip to collector distance. These, when we supply high voltage, the flow of electrons will be high. So of course the fiber speed coming out will be high. So when the fibers are coming with a speed, it will have more stretch and the fibers will be fine. And feed rate, we have to adjust accordingly. If we reduce feed rate, the voltage will accumulate number of electrons on the tip and the fibers will not come out. So whenever we have to prepare new solution for electrospinning, we have to optimize these parameters. And tip to collector distance, I will also describe these parameters later, 6 and 7. And here I'm going to discuss angle of electrospinning. This is new parameter which we introduced in our research. So when we do electrospinning, we put a collector in front of the tip. But when we utilize it on different angles, like this is angle of electrospinning, and now we are putting at 0 angle collector, so we are getting normal fibers. But when we are putting at 45 degrees, we are getting a convoluted fibers a little bit. And when we are putting collector at 90 degrees, we are getting loop formed nanofibers. So it depends on the conductivity of solution and viscosity of solution. Depends. Some fibers at 90 degrees, even they can be smooth with smooth morphology, like at this 0 angle. And this is voltage supply. For normally for electrospinning, we use voltage supply from 3 kilovolt to 30 kilovolt. It can be more or less, but normally for different types of available polymers at the moment, we can see this an average in the reports. And number 9 is humidity of the system. Humidity and temperature of the system will affect on the solution properties. So solution properties that is described in number 2 are very important. So we have to take care of humidity of the system and the temperature. So the viscosity of the solution should be maintained. There are a variety of polymers available, and different polymers have different properties, not only morphological properties, but chemical properties and physical properties. So this is natural synthetic polymer, polyvinyl alcohol. We can see this is soluble in water, and the morphology of nanofiber we can see here, very smooth, and this can be electrospun between 8 to 10%. Polyvinyl alcohol is water soluble, so it can be edible, like we also can utilize for biomedical application and sometimes eating as well. And there are different types of polymers available having different morphologies at different current, different voltages. They have different applications depending on the end use we utilize, like nylon. Wherever we need strength, we use nylon. Where we need luster, we use silk. and where we need a biomedical application with average strength and stuff, then we use cellulose acetate nanofibers. And where we need firm and stiff fibers or a stiff application, we use polystyrene because it's stiff in nature. So we can take polymer depending on its properties and try to solubilize in any solvent, put high under electrospinning machine and take nanofibers and try to sort out that for which application it is suitable. Normally natural fibers we use for biomedical application, and synthetic fibers we use for artificial optimization or where high strength is required. Sometimes what we do co-electrospinning. We put two syringes with different polymers, natural and synthetic, and it can combine together to get ultimate fibers with ultimate applications. So this is polymer solution properties, like I described before: conductivity, viscosity, and pH. So conductivity disturb the flow of electron during electrospinning. If the flow of electrons is disturbed, it can form spray or it cannot form the fibers because the accumulation of electrons on the tip. Viscosity is the main to flow the solution to form bead-free fibers. And if the viscosity is very low, it will form spray, not the fibers. So we have to be careful with this parameter as well. And pH changes the conductivity. So ultimately conductivity will be disturbed if the pH of the solution will be disturbed. So we have to be careful with the pH as well. And as I told you that I will describe later, the diameter, effect of diameter on electrospinning. So these are different electrospinning tips we can see with a different diameter size. So when the diameter size is small, this is smallest, like we can see the thin diameter. So it is giving us thin nanofibers. And when we utilize thick diameter of tip, we are getting thicker nanofibers. And the distance is also playing an important role, the distance between the tip and the collector. When we decrease the distance, the stretch is very low. So when the stretch of fibers is low, then we will get thick fibers. And where the stretch will be high, we will get thin fibers. So these are two to three parameters which we have to collectively play together with them to produce the fibers depending on our end use application, whether we need thick fibers or thin fibers. And this is electrospinning collector type. Electrospinning collectors can be different, which is as I described in the first slide, like when it's negatively charged electrode, it was just a cylinder. But when we change the shape of cylinder, what will be the effect on the nanofibers? So this is a normal cylinder shaped rotating cylinder, which is plain. There is nothing on that. And this is rod type cylinder. So when there's a rod type and it's moving, and its rotating speed also plays an important role in changing the shape of fibers. And this is high speed rotating disc. So when there is a disc, it also give us different morphology, like highly aligned nanofibers. Wherever we need, we use either rotating disc or either parallel rod as a collector. When we use this rod, we get nanofibers in between, like linear nanofibers in the form of lines. This is a normal collector, stationary. Any metal, any aluminum foil can be in front of the fibers. Where we need random alignment, we are not bothered with the alignment, then we can use a stationary collector. And sometimes for fibers we need to do some reactions, chemical reactions. So this can be the liquid bath as a collector we can use. So this can be water, this can be alkali solution, this can be acidic solution, depending on the end chemical reaction we want into the nanofibers. So we can directly collect nanofiber on this water or any liquid bath. This is another advanced technique in which we can save the time of reaction, because when the fiber surface area is high, it can react easily here in this one. But when number of fibers when collect together, they will have high surface area. So it will be very difficult for the solution to reach inside the fibers and make any possible reaction. So these are various collectors. There are also variety of collectors depending on the end use. So If you have any idea, you can utilize any new collector, any new metal in front of electrospinning and try to sort out that what it has any effect on the morphology or properties of resultant fibers. We are working on nanofibers because this is the nanofiber global trend until 2025. We can see that the blue area is telling us that in the world, these are the countries utilizing nanofibers at high scale. And the patents and productions of nanofibers is also increasing year by year. We can see in 2016, there were not much progress, but when we see until 2024, the expected growth is more than half. These are the reasons we are utilizing nanofibers, because of their versatile properties. There are applications of nanofibers. So nanofibers can be used for versatile applications. It can be used for energy applications, it can be used for biomedical applications, textile applications, protective clothing, tissue engineering, wound dressing, fuel cells, and filters. And also these days, beauty products are also being commercialized because the production rate of nanofibers has been increased. So we can utilize these for beauty products as well. Now let's come to the research, and this is this idea that there are a variety of natural ingredients available on Earth, like garlic, ginger, onion. These are the things we are using on daily basis. So as I said, that these products, nanofibers, are widely being utilized for beauty products. So we can simply incorporate such juice from garlic or juice from ginger into the nanofibers and check the application for either biomedical or either beauty products like face masks. This is major issue of water. Earth is running out of water. So there will be no water by 2040 if we keep doing what we are doing. So we are not taking care much of water. Water is being utilized for even good and bad applications. So in Indonesia, 59% of the rivers in Indonesia are severely polluted. This is one report which says that 59% of rivers in Indonesia are severely polluted. So what is the solution to get rid of this pollution? One is like make awareness among the people. Second is to do some advanced and conventional treatments. So it is the responsibility of us, we researchers, the textile researchers, to prepare such type of membranes which we can utilize to remove this kind of toxic and hazardous material from wastewater. So these in nanofibers, the production cost seems very high, but it is recyclable in its high surface area. We can get very good adsorption and filtration effect. So we can utilize in conventional methods. They have to utilize those and dispose in the form of sludge. So this is not good. They utilize, they clean, and they again put those material back into the water. So this is not a good idea. We have to think about it, that what to do either with this conventional sludge, or how can we utilize the nanofibers or nanofiber based membranes combined with conventional fabrics to get this done. This is the graph which is saying that direct supply of industrial use, industrial water system, irrigation, these are the percentages of Japan which we are using from 2016. But the what we say, the recyclability of water is very low. So in Fukushima these days, 1 million ton of water they just throw in the sea water. So it's not good. So we have to think something. What we are thinking is we are utilizing nanofibers to remove such kind of hazardous impurities on Earth or inside the water, like volatile organic compounds, carbon dioxide, or even viruses and bacteria. If they are available inside water or in the air, we can absorb or infiltrate using nanofibers because of their small fiber size. There are hazardous material like arsenic, boron, and sometimes there is oil spill in the seawater because of transportation of oil from one country to another country. If there is oil spill, we have to save that oil as well. So we have to take some steps and make awareness among the common public and the special public as well. Try not to waste water is ultimately saving water. Utilize advanced and conventional methods collectively to save water and water resources. My suggestion is to use nanofibers, which are efficient for removing industrial waste, dye, heavy metals, oils, and volatile organic compounds from wastewater. But it's expensive, so we scientists have to think about the cost reduction and increase the production. These two things are the challenges in the production of nanofiber at the moment. So we have to think and come up with the solution. How we are filtering the oil from water. This is one video which can tell us that how it can change. It can filter the water. It can separate the water from oil. So this blue color is water. Blue color is water and the red color is oil. And here is the nanofiber layer. So see how water is coming down, and water is coming down here and the oil is going the other side. So this is 99% pure oil which is separated from this oil. This is another project we started now, in which we are trying to utilize two types of different polymers, which one can eat. So this is zine polymer. Zine is prepared from corn, the corn we eat, and PVA is synthetic polymer, which is water soluble, which also we can eat. So we try to put different ratios of these and incorporate any drug inside, like rifampicin drug, which is used for tuberculosis patient. Tuberculosis patient, he has to take different amount of medicines in a day at different times. So we can optimize different dissolution rates of this PVA and zine together and get such kind of nanofiber membrane which can be edible, and it can stay inside the stomach for a number of hours and release the drug as required, as per requirement. So we can control the release by taking the solubility of different polymers. So PVA is highly soluble and zine is semi-soluble in water. So they both have different solubility. We can play with the solubility to get our required achievement done. This is an idea of making some drug which can stay longer inside the stomach. So nanofibers are inside the capsule. This is just an idea. Once the capsule is released in the stomach, the nanofiber layer comes out of it. So we can control the time in what time it can be dissolved inside the stomach environment. So the size of layer will be big enough so it cannot penetrate inside the gastric retention. Until 8 hours it can stay, but we have to optimize the parameters, and after 8 hours it will just pass through the stomach line. So this is just an idea we are trying to prepare by combination of different types of polymers which can stay in this size for a longer time in parallel to the release of the drug. different polymers will release the drug inside the stomach, and other polymers will stay longer in the same shape inside the stomach environment, because there are many acids and stuff. So those polymers should stay until 8 hours inside the stomach. It's very difficult, but we have to optimize some parameters to get this done. We have to play with the type of polymer, the shape required to achieve this goal, and the sufficient strength which can retain its shape during the release behavior inside the stomach. Currently, there is a big issue of coronavirus. The coronavirus in the environment is a very big issue, and a variety of face masks are available in the market, but they are not based on nanofibers. So there are different problems we are facing when they use number of layers. Of course, there is humidity problem, uncomfortable environment, when a little bit saliva can come on the mouth because of not very good breathability. And for functional purposes, we also require fire resistance or UV light intensity resistance. So breathability problem, acne on the nose or face, uncomfortable mask, bacteria, and no virus protection. These all were the problems still we are facing after coronavirus, because we have to wear the mask. So there was no any other choice. So what we had to do, we have to optimize mask in a way so we can utilize mask without these problems. So how we are tackling the problem? First, we are introducing nanofibers because of their fine diameter. The virus size is very small, but nanofiber pore size is smaller than even viruses, so virus cannot pass through. Another thing is water molecule is also bigger than the nanofibers, so we also put one hydrophobic layer and then nanofiber layer, so the water cannot pass through it. And this saliva can be released from this in the form of vapors because of the temperature adjustment using this alpaca wool. The wool fiber is a very good fiber which have a temperature regulation. In summer season, it gives us cold effect, and in winter season, it gives us a little bit hot effect. So we are utilizing this. Of course, it's a little expensive, but at small scale, it can be considered because of several side effects, as I mentioned in my previous slides. And the air can pass through this nanofibers, and breathability can be very good because of high porosity. But the thing is, we have to optimize the layer. We have to use very small layer. There is one challenge. The challenge is to get same size of nanofibers. If there are no same size, then we have to increase the thickness. That may cause the breathability problem. But if we can prepare the fibers with the same nanofiber size, diameter size, then this will infiltrate number of viruses, bacteria, and even dust particles or pollen particles. So we can utilize such kind of membranes in between of this cotton layer and this wool layer. And such kind of membranes will be very useful to make a face mask based on nanofibers. There are also other applications like artificial blood vessels. There are a variety of blood vessels available in human body, and we need surgical operations. Either we have to take conduit from our different body parts and put there, or we have to put some artificial blood vessels based on rubber, and those we have to take it back with second surgery. But when we utilize nanofiber, we only have to do single surgery. If we take any other nerve from any other part of body, we have to do 2 operations at one time. If we are using rubber as a conduit scaffold, then it will cause the second surgery to take it back after regeneration of that nerve inside our body. Or third option is this one: we prepare nanofiber based artificial blood scaffolds which we can put inside, and it will be degraded with the time inside our body in the biological environment, and we don't need any secondary surgery. So in the body near to heart and around the heart, there are different parts where we can get sometime a nerve injury or nerve blockage. So we have to replace in the form of bypass. Here is one challenge of making Y-shaped artificial blood vessels. So it's very difficult to make a Y-shaped artificial blood vessels. So if someone have an idea, people try to prepare, but like this T-shape they prepared, but there is still some hole, but it's not used. It cannot be utilized for practical applications. So this is one idea we can work on. There is one lightweight raincoat. Normally raincoat are heavy and air cannot pass through, like breathability is a big issue in that. So if you use nanofibers, nanofiber can let the air pass through it, but water cannot pass through it. So we can just laminate this with any cotton or polyester fabric and wear in the form of lightweight raincoats. This kind of raincoats are available in the market, like Gore-Tex company is very famous company which is making such kind of raincoats which are available in the market. And as I described before, there are variety of ingredients are available, like turmeric, ginger, and aloe vera. So such kind of ingredients we can take and put in any solution or incorporate in electrospinning solution and the form nanofibers in this form of beauty mask. Because it has high surface area, so it will have more effect with small concentration of ingredient we are utilizing. In conventional mask, there are like huge amount of material is utilized, functional material is utilized, and they have to keep it in the liquid form. But what we are thinking to make is to make it in dry form. Just put a little bit spray of water on it and then apply on your face to get face beautiful. And this is a lightweight conductive material. We are using iPhones, we are using smartphones, like those size are very small, but it's still like weight is light, but still it needs to be lighter than this one. So for that, we can avoid that by preparing these lightweight materials. We can put different kind of ionic materials inside these nanofibers to get metallic or conductive nanofibers. So this we can see here in this video. This is LED and this is just nanofiber. So these are nanofibers which can be utilized as conductive material instead of utilizing gold or platinum. We can utilize such material which are anti-corrosive and lighter, even lighter than those gold or platinum materials which are being utilized in very expensive smartphones. And this material is stretchable. There is one stretchable material is called spandex. You are textile engineers, I think you are familiar with spandex or lycra, which is inside the fibers to get a stretchability. We took those spandex fibers and solubilize again in the solvent to recycle it in the shape of these lightweight and conductive materials. Nanofibers can also be utilized for food safety applications. There are a variety of sensors available which can detect ammonia dioxide, carbon dioxide, or even the emissions from greenhouse. Those we can absorb on nanofibers and collect it and reuse in the different formats. Food also produce methane gas. So that methane we also can capture and reutilize to use in our homes for fire or in the industries to get the heat energy. And these nanofibers in Japan being utilized to cover the crops. The crops of grapes are to be covered with this to avoid the insect attack on this, like fruit flies and stuff. They come and they just eat these highly expensive and low productivity grapes in Japan. So we just cover with nanofibers because air can pass through it, and the light particles also can go inside to give food to the grapes, but the insect cannot come inside and damage the crops. There are like indole based dyes which can be utilized to take a switchable response from these nanofibers. Because of nanofibers have high surface area, if we incorporate any ingredient, it will give us high performance compared to normal fabric. In the form of wound dressing applications, if we see, like on wound dressing, nanofibers are preferable because they can form cells very rapidly compared to any other normal surface, and its three-dimensional structure gives scaffolding properties on the skin, so it can be utilized for biomedical applications, sensor applications, textile applications. We use these fibers for coloration and dyeing. At the moment, dyeing and coloration are not like suitable, we can say, because at industrial level, industrial scale, they are not being utilized at high scale. But we need the engineers and the textile students, textile engineers like you, who can produce their own industries based on nanofiber products. They can be recyclable and they can be disposable products, reusable, to make environment green. Thank you very much for your kind attention. And if you have any questions, please feel free to ask. And one other thing I'm going to add is, if any student is interested in research, so I will be happy to guide and assist them. Please just feel free to contact me. Take my email address from Reena, Dr. Reena, and just send me email and I will respond you. Thank you so much.
Okay, thank you very much. Can you hear me? Okay, yeah.
Yes.
Okay. Thank you very much for Dr. Engineering Muzammil Khatri for your really amazing lecture. Like, I think Electrospun Nanofiber is still new for us, especially for other graduate students in here, because like some of researchers are also like national institute in here. We are also working at the nanofiber, but it's still news for us because like maybe not a lot of technology that we can use in here, or also like some knowledge that we really need to to upgrade. That's one. And okay, let's move it to the next agenda, which is the Q and answer. So please, if you have any question, you can just write it in our chat box, or also you can raise your hand. If you are stay in the classroom on the student, you can raise your hand and Miss Febri will help you. And or maybe you can also raise your hand through Zoom meeting, maybe. Okay, let's a moment. Okay, maybe we can see from the chat Zoom for Mr. Firdaus Muhammad. You can ask directly if you want. Please, you can going. Is this okay, Mr. Firdaus? Okay, or maybe I will read it. Okay, Dr. Ajari Muzammil Khatri, this some of the question from the chat. So sorry, sir, for permission to ask in the advance. Let me introduce myself, Firdaus Muhammad, a final student from the Indonesia, from UEE Management Study Program. What I want to ask is how to apply and tips for the presentation of the material today you gave for today event.
Thank you,
Okay.
Mr. Firdaus, for your question. Is it about the tips like for the presenting tips, or it's related to the materials? presentation materials that you gave for today's event?
Mr. Firdaus, maybe you can answer.
Okay, I'm going to give both
Okay,
answers.
Just give it.
Okay, so the tips for the presentation tips is just to look at the head of the audience. If you are hesitant, you don't need to worry about anything. Whatever you speak in front of them, you should have confidence that you know that thing very well, and whatever you know at the moment, you can speak up. If you don't know anything, it's not a big deal. You can tell that I can come up with the answer in the future, and you can study well and get them via email later. This is like to give tips for presentation. And if you are talking about the tip of nanofiber, then you can just take any syringe. I hope if you have an electrospinning setup, then there is one syringe. Syringe is the same which we use for injecting any patient. So take the pumping stick behind and put the tip on the top of electrospinning syringe, and you can connect it via any clipper, electric clipper, conductive clipper, and supply high voltage using electrospinning machine. I hope I could answer with what are you asking.
Okay.
Rina, I don't know if he is asking this question or something else. If he is asking something else, please explain to me so I can answer well.
Yeah, sure. Wait a moment, because I contact Mr. Firdaus. Maybe he has another question of this is the right. Okay, or maybe it's okay if he still not agree with your answer. Maybe he will ask again. Is this okay for you, Dr. Muzamil?
Yes. Anyone can email me later.
Okay, thank you. So I think we got a student from the class who wanted to ask you directly.
Okay.
Please to Miss Febri. You can continue.
Okay, thank you, Ms. Rina. One of our students named Ishak would like to ask to Dr. Muzamil.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Hello, Mr. Muzamil Hatri. Good morning.
Good morning.
Here I have some question. Before that, I want to introduce myself. My name is Ishak Amrullah. I am a student of textile engineering.
Okay.
I have a question. The first is, I would like to ask a question. What is the dangerous potential when we use or apply the technology of electrospinning? That's for the first question. And then for the second question is, how to maintain nanofiber continuously and such a cloth can be minimized. Maybe that's it. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you for your questions. Your first question is what is the danger of electrospinning to human? So one thing danger is because we supply high voltage during electrospinning, so that high voltage we have to be very careful when we go near to the electrospinning machine, and whenever we want to change any parameters, we have to close electrospinning machines properly and then turn on again. And the second hazardous is there are some polymers in which we have to utilize very hazardous solvents. So to handle those solvents, it's better we use fume hood. Those are highly volatile solvents. Sometimes they can cause cancer even when we inhale them for a longer time. So we should use fume hood for the preparation of such kind of polymer solution in which hazardous solvents are being utilized. Hazardous solvents are like trifluoroacetic acid and morpholine based solvents, or even dimethyl formamide, which is commonly used solvent, DMF. It's also can cause such cancer effect when it can be inhaled for a longer time. So we have to utilize fume hood in order to be safe. And we also can utilize special masks which are made only for such kind of experiment. So you can breathe well, but the solvent effect will not touch inside your nose points. And the second question is, what is the impact in the application, right? Sorry, Rina, what was the second question?
Yeah, I think it's right. The impact of application, maybe, wait a moment. Miss Febri, can you give it to Exha again?
Okay.
For the second question is how to maintain nanofiber continuously, such a cloud can be minimized.
Okay, thank you. I forgot to note this question. Yes, to maintain nanofibers, we have to play with several parameters, as I mentioned in my slide. These are several parameters on which we have to play. Like, first parameter is to select the polymer concentration. What is the polymer concentration, which can make the viscosity or conductivity or pH of the solution, so it can be electrospun in the form of fibers when we supply a voltage. Second thing is how much voltage we should apply. We should try voltages from 3 kilovolt and onwards, like slowly 3, 5, 10, 11, 12. So wherever we are getting small amount of fibers, even with the spray, then we can adjust around that. For example, we are getting fibers at 10 kilovolt, then we can adjust either at 9, 9.5, 10, 10.3, 10.5. Like, as we adjust the frequency of radio, we have to adjust the concentration, voltage supply of the electrospinning. And some fibers can be electrospun with thick diameter of needle tip. Some fibers can be prepared at the thin. So we have to check both diameters, whether it's working on small diameter or a big diameter. And feed rate can be controlled at any time. As far as a small amount of feed rate is applied, it's fine, but we have to just control that feed rate. So more fibers, more polymer solution is not coming, like it's not blocking the polymer tip, or it's not coming out in the form of polymer or filament. It should come in the form of fibers. So we have to check everything one by one. First polymer concentration, and then voltage supply, then tip to collector distance, and then feed rate at the end. And also we have to check the literature in the, like, what kind of polymer we are utilizing. If it's new polymer, of course we have to optimize all parameters. But if you are finding any report article already published, you can check and try to do it. Sometime what happens, our electrospinning machine have some error, or electrospinning machine model is different. So we have to optimize according to what we have at the moment. And the system conditions are also different sometimes. Like moisture of the system, maybe normally we use 45% for a variety of polymers at the moment. But some polymers may need high moisture region because of their highly electrostatic, or conductivity of solution is very high, so they can block. So we have to avoid this electrostatic effect and provide high moisture. These are some parameters we have to play with to get nanofibers smoothly. So some polymers cannot electrospun, so we have to play with feed rate. And some polymers are easy to make nanofibers without cleaning their tip again and again. So it depends on the polymer type and polymer behavior after we are making a polymer solution. Sometimes we have to change the feed rate again and again. So in that case, we have to change the solvent. We have to change the solvent with a little bit twisted properties like conductivity or pH. So it can maintain the viscosity, pH, and conductivity in order to form the nanofibers.
Okay, thank you very much for your really clear answer. So what about Isha? This is okay for you to know the answer and also information about the electrospin? This is okay? Huh? Okay, thank you very much for Isha.
I don't know if I was very fast, so he can email me again and I can give him precise answers again. Like at any time during his experiments, even he can ask me and I will answer his email.
Okay, thank you so much. Okay, I think it's okay for Isa. So, and I got the chat again that's in the classroom. Wait a moment. There are one student also wanted to ask you some question. So, Miss Febri, please help some student to ask.
Okay, thank you, Miss Rina. There will be one student that I want to ask. Her name is Chita. Okay, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
My name is Shiva. Okay, I want to ask you, as we know, the textile waste one of problem in this world. Okay, my question is it possible when we apply nanofiber technology in the textile industry, the waste of textile will be reduced? Sorry. Is it clear now?
Sorry, I couldn't get answer. You are asking me that how we can introduce nanofiber technology to be utilized in textile industries. Am I right?
No, I mean if we apply the nanofiber in the textile, is it a waste of textile will be reduced?
Sorry, I cannot hear you. Irina, can you hear her? And
I think like, for example, if you wanted to use nanofiber and apply it into textile industry, and which one I also don't, bahasa Indonesia? Yang terakhir apa?
Sampah tekstilnya bisa berkurang.
Limbah tekstil. Oh, okay. Okay, thank you for Siva. Dr. Engineer Muzamil, if, for example, we use the nanofiber product, so that nanofiber product we wanted to use at textile industry, and like, for example, no, our problem in the textile industry is like we have a lot of what the name? Waste. Like a lot of waste that we product from the textile industry. And if we use nanofiber, can we decrease the waste of the textile industry or no? What do you think about that one?
Yes, of course, we can decrease the waste because in the production of nanofibers, we don't waste much. First is this one. And second question, I think, is related to the industry's waste. The waste from the industry is coming and we can treat that waste or not. Yes, we can treat that waste because from industries, there are variety of waste coming out, like volatile organic compounds, heavy metals, and dyes. So nanofibers, because of their high surface area, we can use them as very good adsorbent. So in water, in a wastewater, if we put suitable nanofiber inside and keep it for a long time, then different kind of impurities just attract on those nanofibers for a long time, and then we can take nanofibers out with those impurities, and the water at some extent we can clean and reutilize it. And that nanofiber layer, we again can clean it and reuse it. It's called fouling effect. So we have some fouling affected nanofibers which we can utilize, and we can reuse in the form of textile adsorbent for removing such kind of impurities from waste water of the industries or waste gas of the industries.
Thank you for Dr. Muslim. Maybe I will have like another continuous question. Like
Yes,
for
yes,
example,
sure.
right now, like the nanofiber products, as you said before, that this is from raincoat layer. This is, isn't it?
Yes.
Yeah,
Yes,
and for the nanofiber product, can we use directly into garment or into what the name, textile, for example, fashion, or yeah, like fashion, or like without becoming the layer, like just directly use it?
Yes, directly we can utilize some fibers are available like polyester fiber, which is handling property is very good. Yeah, polyurethane, but the thickness of fibers we have to get is should be very thick. And for making thick layer of nanofiber, it's highly time consuming. So nanofibers are not directly for wearing for apparel. It will be expensive as well for us. So better to just laminate it with any other fabric like cotton or polyester, laminate it and then utilize it. We can get functionality using nanofibers, but directly it's not suitable. We can use it, but it is not suitable because of its high cost and high time for the production.
Okay, thank you so much. So I think another student wanted to ask or have some question from the classroom? No? Miss Febri, maybe you can help me? Miss Febri, can you hear me? No? Wait a moment. Okay, for the participant, we also send you a link for the participant to fill the form to get our e-certificate. So, kepada audiens bisa mengisi absensi di chat Zoom untuk mendapatkan e-certificate pada general lecture pada pagi hari ini. And another information, so if you are lucky and you are really active and ask some question through this general lecture, so you will get the door prize or gift from our textile engineering department. So I think still have 2 people. If a lucky student, if you wanted to ask some question.
There's one question.
Yeah, sorry.
They will get the prize.
I think there is one question.
Okay.
But it's in Indonesian written.
Oh yeah. MIPA, yeah, from MIPA.
Sorry, I didn't read it.
It's related to one of my publication.
Oh yeah, sure.
Photo response.
So from Aris, Pharmacy FIPA UE. The article, this is, yeah, it's about your article or your journal. So yes. In your article, photosynthetic nanofiber for data recording and erasing,
yes.
Jamil Katri et al. 2020, that said that the application of nanofiber for what's the name? For QR writing, and also to wait a moment. Like in your paper about the photosynthetic nanofiber for data recording and ear singing, and yes. And that said that you can eraser and also you can delete and also what the name? You can delete the QR code using temperature at 40 degrees Celsius, And actually, this is already used in the real application or still in the research under research. Can you get my question?
Yes, I got it. Actually, we completed this project, but like no any industry is using at the moment. It's only in the form of article. So there is one indole based dye we used that is a big structure name. So at the end we call it indole based dye. So this dye, when we incorporate into nanofibers, the double bond from oxygen is break when it's exposed to UV radiation, ultraviolet light. When it's exposed to ultraviolet light, the double bond from oxygen in the indole structure is breaks. So when it breaks, it forms some color. So in our case, it forms like blue color. And after this blue color is formed, we put under halogen bulb, or we can say it's 40 degrees centigrade near, we maintain the 40 degrees, and it returns to its original color, which was nanofiber color and like white color. So we put a screen, inverted printed screen of QR code with 1 by 1 centimeter, very small, and we exposed to the UV light. So wherever there was open space of QR code, it was printed on this nanofiber in the coloration of UV light. So that UV light we can assess using a QR code reader. This is our main motive to prepare. Like this is for the application for transportation from one part to another part for food or any medicine, which we need it to transport under 40 degrees centigrade, because under 40 degrees centigrade, if the temperature exceeds 40 degrees centigrade, then the color of nanofiber is changed, turned back to the white color. So we don't need this QR code to be removed during transportation. If this QR code is removed, we will understand that this product is not transported under 40 degrees. There is 40 degrees temperature exceeds during the transportation. So this research is for food security application in the form of sensors, nanofiber based sensors.
Okay, Mr. Aris from Pharmacy, FMIPA UI, this is answering your question.
Ya, terima kasih. Thank you very much.
Yeah,
It's for food security ya. Jadi seperti untuk merecord suhu gitu ya. It's for temperature recording.
Yes, I think so.
Yes.
Is it for temperature recording?
Yeah.
It's for QR code recording data, like QR code or barcode. This is some kind of data. So when we can imprint that expression in the form of QR code on the nanofiber, it's a recording data. And if it's, when it's exposed to temperature more than 40 degrees, this data is erased. So we need this data during transportation. If it's erased, we can understand that transportation is not done well. So we can claim that the transportation is not carried under the conditions we wanted, which is under 40 degrees or below 40 degrees.
Rina?
Terima kasih.
Sorry, please. Okay, thank you so much, Dr. Muzamil. This is okay?
Yes.
Rina?
Okay.
I want to ask.
Yes.
Mr. Muzamil, can you show the slide about parameter of electrospun?
Yes. This one?
Oh yeah, this one. Okay. Yeah. May you explain about the fifth parameters? That's fifth rate.
Yes.
Yeah. Okay. Yes, you can explain about that.
Yes. Normally, what we do during normal experiment when we start, we take the feed rate of gravity. Like we put electrospinning syringe at some angle so the solution can drop off up to the needle. But nowadays, feed pump is utilized. Feed pump is a pump which press the solution, polymer solution towards the tip slowly, and we can set the feed rate on that, like 1 ml per minute or 1 ml per hour. So we can set and we can check which feed rate is suitable for the solution, and we can choose this keeping some parameters in our mind, like viscosity and its flow, or the needle tip we are utilizing, how much size of fibers we require. These all things we have to keep in mind to set this. But the main motive is that we are getting nanofiber consistently or not.
Yeah.
So we have to set that feed rate according to the consistency of nanofibers.
I see. Okay. Yes, thank you very much, Mr. Bojamin.
So,
yep. Yeah, I see.
I could answer your question.
Yes, I think so.
Yeah, I think so. Thank you.
Thank you so much.
Okay, thank you so much, Mr. for this topic. So maybe another question from the Zoom? No? Or maybe from the class? Yes?
I ask something about electrospinning, Mr.
Sorry, Miss Nothing.
All right, I would like inquiry about
Okay.
electrospinning, because the product is a nanofiber, right?
Yes.
All right. Like this is at your presentation. There's 9 parameters directly affect to the spinning, right?
Yes, there are like these 9 basic parameters. There are also other parameters.
All right, yeah.
But basically these are 9. Yes.
My question is, have you tried? This is a polymer. It's a polymer with polymers. Have you tried with use of natural polymer for the make a natural fiber to make a nanofiber, something like that? Have you tried it?
Yes, we have. Yes, we have tried to make 3 types of natural fibers.
Yep.
One is silk fibrine nanofibers, it's from silk, and second is zine nanofibers, which we eat. Like corn, we eat, it's from corn, and third is chitosan, to form nanofibers.
One nanofiber, that's silk. You tried already. Hello? You try?
Yes, we
from
are.
silk,
We
right?
have. Yes, we have. Yes, we have prepared from silk fibrine nanofibers.
Because polymer solution is quite different with polymer synthetic, right? It's like that.
Yes, it's quite different actually. We have to make silk solution by different mechanism, not normally just by mixing the polymer and solvent together. We have to use ionic solvent to dissolve the silk first inside, and then we have to do dialysis, so the salt can go out and silk only remain in the water, and then we adjust the pH using acetic acid, and then we can prepare nanofibers through it. Sometimes we also have to utilize polyethylene oxide or PVA, water soluble polymer, to just assist the electrospinning, because silk is not easy to electrospin. So it's a complex process to make silk fibrine nanofibers.
Because you have to split off between fibrin and resin, right?
Yes.
So this is very difficult.
Yes.
You can try for the next time. We can work together, join research how to develop a natural polymer.
Yeah, sure.
Yeah. Okay. Thank you very much.
Please email me and we can collaborate.
All right, sir.
Thank you so much.
Thank you so much for Mr. Asmanto, and thank you so much for Dr. Muzamil Khatri. Yeah, I think it's really good about nanofiber, and I think if you know Dr. Muzamil Khatri in Indonesia, especially in the textile engineering department, we are really wanted to to improve the characterization of the natural fiber. So a lot of our lecturers in here have research about natural fiber, such as it's not only like silk or but we also use like from the cellulose, because we have a lot of cellulose in here.
Okay.
And like for example from the banana, the book apa mas?
Yes, yes, banana leaf fibers.
Okay, banana as well, or bamboo, or also another a fiber. That's one. So yeah, that's really interesting.
Yeah.
And I think some student wanted to have a question, or maybe another lecturer from textile engineering department. Miss Febri, have any question from the classroom? Miss Febri, can you hear me? Or maybe I will read from the chat box. Wait a moment. Cukup.
Yeah, I think it's enough maybe.
Okay. I think it's enough. So no question from the classroom, and also no question again from the Zoom. And also I think we already come to like the time is over, almost over, Mr. Dr. Engineering Muzamil. I think I wanted to say thank you very much for you to share the information and also share the knowledge about introduction to Electrospun Nanofiber and potential application for us, textile engineering department in Indonesia. And I think a lot of knowledge that we can get from today's lecture, and also it's really have like broadening. We also have like the information and also knowledge about Electrospun Nanofiber, as well as from the student, our student in here. And we really appreciate and really happy if we can join our collaboration research in the future. So I think, yeah, if some lecturer in here that wanted to have the collaboration, we can like, yeah, contact Dr. Muzamil later. So okay.
Sure, Rina. Thank you very much. I will be looking forward to the emails and collaborations.
Yeah, thank you so much.
Yes.
So, ladies and gentlemen, I also wanted to say thank you for all of you, the participants that joined us during the general lecture, and the students that stay in the classroom to listen the general lecture, and also for head of the Department of Textile Engineering, UEE, and also another lecturer and also researcher that joined us through the Zoom meeting. And we can give us a virtual applause for the Dr. Engineering Muzamil country. Okay. Okay, thank you so much for our student that in the classroom. And I would like to, oh, sorry, they have information in the chat box. Okay, we will inform you that the participant who will get the door prize, congratulations to Firdaus, Mr. Firdaus, Mr. Aris, and also to students from the classroom. This is Mr. Isha and also Miss Eva. Please, you can contact us through the WhatsApp. Bahasa Indonesia ya, 0857 6904 6856, atau Mr. Budi. Please, you can contact him and we will arrange the door prize from you. Okay, and I would like to give you another information that we will have still another international guest lecture or general lecture that will be held on June 29, 2022 with the topic of sustainable textile. So introduction of sexual, and its potential application. And this will be given from the section University in Netherlands. So don't forget to join with us again. And please visit our website at textile@uii.ac.id or follow our Instagram at rekatex.uii, and a certificate will be sent you by email in maybe 3 working days. So please be polite to waiting for that. And we also wanted to inform you that new student registration to our textile engineering department for bachelor degree is also still open. So visit our pmb.ue.ac.id. Okay, ladies and gentlemen, I think that's it all. So let us close our event today by reciting Alhamdulillah.
Alhamdulillah.
Thank you, Rina.
Okay.
Thank you, everyone.
Thank you, Mr.
Thank you very much
Muzamil.
for Dr. Muzamil. Thank you very much for
Waalaikumsalam.
student and other. Billahi taufiq wa hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Yeah, thank you so much.
Ini pengalaman pertamaku memasuki gerbang Universitas Islam Indonesia. Menyusuri trotoar dan ruas-ruas jalan yang rapi, menikmati taman-taman yang terserak di setiap sudut kampus, mengagumi arsitektur-arsitektur yang khas dan penuh makna. Juga sikap ramah yang penuh kesan. Langkahku terhenti di sini, di ruang megah yang menerbitkan jutaan sensasi.
Foto sesi, Mbak Rina. Sudah.
Suasana sunyi para pembelajar memesrai ilmu pengetahuan.
Lupa tadi ya?
Dan aku membayangkan duduk di sana.
Udah tadi. Oh ya. Ya, coba di ini lagi. Mr. Muzamil belum live kan?
Memulai sebuah titik penting untuk merancang masa depan.
Hai, aku ramal kamu akan kuliah di Prodi Rekayasa Tekstil.
Okay, Mr. Muzamil or Dr. Muzamil, are you?
Excuse me,
Okay.
Miss Rina.
Okay.
We would like to take a picture with Mr. Muzamil, and then in the class, we would like to take some photo.
Okay. Wait a moment, Mr. Muzamil. You cannot leave. We wanted to take picture together with you from the classroom. So just stay in that, then give your best smile.
Sebentar ya, lagi di kondisi ruangannya.
Oh, okay. Wait a moment.
agak jongkok, yang di depan, yang di samping boleh berdiri, yang di depan boleh.
Yang ambil foto siapa, Mbak?
Mbak Rina mungkin bisa.
Yang tinggi di
Sini, Allah, sini masuk sini dulu.
Come on.
Okay, please be ready. Excuse me, Dr. Muzamil, if you are
Dihitungin, Mbak.
here in the class.
Okay.
Okay, 1, 2, 3. Dia close.
Enggak di aja.
Okay, one more time. 1, 2, 3. Okay, thank you so much, Dr. Muzamil. Who have been waiting for us.
Okay, thank you so much, Dr. Muzamil. I think, yeah, everything is enough, and yeah, you can leave this meeting.
Thank you very much.
Maybe I will close. It's okay, Bu Febri. Okay, I think it's enough. Okay, thank you so much for Dr. Muzamil for your lecture today. So yeah, I will close this meeting. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.